Bismillah ar-Rahman ar-Rahim. June 43, June 18, we're in 43, question number 5. So my plan to discuss with you. Okay. So first of all, let's read, then I inshallah start in detail. What a question is. Question is mass is given here 3 kilograms on a rough plane, inclined 20 degrees the horizontal. Okay. So first do rough idea. So it means inclined plane, 20 degree. And it is a mass is given here as a 3 kilograms. Okay. And best habit, read question and write data. Okay, this is very clear. Second is saying a force of P newtons acting parallel to line of slope plane is used to keep the particle in equilibrium. Now he said particle keep in equilibrium. Now problem is there that we have not one way to keep in equilibrium. Two ways are there. Okay, I'll discuss later. Coefficient of friction between the particle and plane is 0.35. So mu is given by him. Mu is given 0.35. Okay, show the least possible value of P is this much and find out the greatest. So it means two possibilities we have. I give you basic idea. I will make two diagrams, one about to move down and what about to move up, because he said system in equilibrium. So equilibrium means confirm a system in equilibrium. So due to equilibrium, we know very well equilibrium. So one thing is a very clear acceleration confirm zero. Why it confirms zero? Reason because particle is not moving up or down. Okay, in equilibrium still. Let's move on next. So I have two things we have total. One, he said least force. I given a lot this kind of example a lot of times, that suppose you are here with your luggage is here and you're pulling up. Look, for example, some angle, or maybe not some angle. Let's say you are pulling parallel to surface, no problem at all. So now you have a least force. So least force means the particle is just about to move down, just about to move. So in this condition, when it's about to move down, so friction is naturally upward. Why? Because the particle is about to move down. You can say that is just going slip down, is slipping down. So naturally, opposing force is a friction. And one plan, we have another one. What is that? If I take in reverse plan, for example, your object is here. Okay, same as usual. Object is here, and you are applying force. Now you call one friend, please come and help me. So there are two friends now pulling up, and a force increased, and now we have to find the largest force. So for example, you are increasing your force, increasing. A time will come, it will start to move up, about to move up. So friction would be downwards. Reason? Because system is going to move upward. I said you, it tends to move or moving. Friction always opposite to that. I hope so. The idea is very clear. And let me erase it now, both ideas, and I'll do a neat, proper way and full question, inshallah, try to complete. First of all, make sure friction is same throughout the both idea. So what is friction formula? F is equal to mu R. F is equal to mu R and mu. Okay, before I start, make a diagram. Two diagrams I will make here. So one diagram I will make like this. Have a look here. This and this. Okay, so one this plane, and second I will make here, because two situations we have. Okay, so this I'm erasing from here. All right, so one particle is placed here, so you applying a force here. So weight component, what is the mass? 3. And all of you know, if mass is 3, what is the weight component? Mg. So m comes here and g is 10, you come to 30. So weight is 30 newtons. So acting downwards is a very clear weight acting downwards. And weight has two components, one parallel to surface downwards and one r upward, and this is a component downwards. So it means weight is a 30 newtons, and this is angle given by him is, the question is 20 degree. And I said a lot of times this angle and this angle always equal. So there's a 20. And if we have a 20 here, so there's 100% 20 cos 30. Sorry, 30 cos 20, because weight component 30 and angle is 20. And this downward weight component acting parallel to surface, always sine. Okay, now because it is r upward, because it's a normal reaction, And you know very well the particle is about to move where. Naturally, he said that is particle about to move. I'm planning that. Let's say this about to move up. So let's say about to move up. So I just make an idea. This about to move, sorry, about to move down because it's a least force. So if it's a least force, naturally about to move down. I'm writing here about to move, about to move. Okay. So when least go down, so you will friction confirm will be opposite back to the against the motion or attend to move. So let's start, and I think rest part we can do easily. And F is equals to mu R. Okay, R component is equals to this one, so we can say, and mu value is given here 0.35, and 30 costs 20. So I can type it and get my answer in 3SF. It's not 3SF, sorry. It's because this is not our final answer. So I will just take the 4 dp minimum, 4 dp. So 9.8668. Okay, newtons. I got a friction force. So this friction force I got from here. Now, according to plan, system is about to move down. So where about to move, I'll start from there. What is the formula I have? Net force equal to MA. Net force equal to MA. Okay, because about to move down, so I will start my applying formula here. So this component minus friction component minus applied force, so is equals to what? 0, because given here. Okay, what is applied force? Did he mention? No, we need to find P. That is called P actually. So I'll give this name as a P. I will remove F name and write P here. So let's start. So 30 sine 20 minus friction minus P equals to, okay, even because system equilibrium, if you start from top or down, no effect. Why, sir? Because particle up and down balanced. That is why. Anyway, so I replace the value 30 sine 20, 30 sine 20. Friction value come from the top here. Okay, so I'll take from there. Oh, wait a minute, please. Okay, so let's take from there the value of we have friction force 9 point, 1 minute please, 9.8668, and this P will come on the right hand side. So I got a P, and just matter of typing in calculator, and we have to prove, and that is coming. If you check it, this 0.394 should come. So let's see it's 0.394 or not, and let me check. I type myself. Okay, let me confirm. 30 times 2 sine 20 and minus 9.8668. Yes, it comes 3 point. I am getting 0.39380, and because we don't want this bigger than 4, so add 1 is a perfectly same answer. Alhamdulillah, Rabbil Alameen. First part is clear. Let's talk about condition number 2. Again, we have a particle here. Again, applied force on the top. Okay, I make again. So let me take my okay. This is our up and down forces acting. Okay, let me make again up and down acting upward. Okay, this is a up and down like this, and there's a weight component downwards. Okay, so let's start. Weight component is what again? 30 newtons. You know it. 30 newtons. Okay, so this is angle 20, and do you know this angle 20 as well? This is a 30 sine 20. This is 30 sine 20. Upward is R, and downward is 30 cos 20. Okay, and applied force P. But now a P increased. He called one friend or applied force more. So about to move up. About to move up. Friction is common sense is the below. Okay, so about to move up. So about to move up. About to means acceleration 0. So I'm starting now. And what's formula? Net force equal to MA. Net force equal to MA. Okay, because about to move up, so I will start from here. So P minus, why are these both minus? Because they're opposite. Minus P minus F, sorry, and sine 20 is equals to MA is 0. So I leave FP here and F goes there. F plus 30 sine 20. So I'm typing the value and F will come from there. Okay, so 9.8668 plus 30 sine 20. So I'm typing in calculator. So 9.8668 and plus 30 times 2 sine 20. And my answer is coming here 20.8 1 Newton's force. So this force we have a need to keep it like about to move up, but still system in equilibrium. I hope so. It means in this you are not relaxed. System was going down, and now a system going to up. So you are relaxed now. I hope so. You got the idea very well.